Let's do another question where it's a lot, a fair bit more complicated or a little bit more complicated, where in general, questions like this, throw a lot of people off because they get really confused. For some reason, it does look like a quadratic function, but embedded inside it, it's got another function, which is may or may not be a quadratic function, okay? You could use the quadratic formula to solve this by saying whatever the box is equal to your quadratic formula. We're going to simplify it down a little bit because I don't want to constantly write down x minus 2 over x, right? What I'm going to do is, and again, that's one of the reasons you use the let statement, to make life easier for yourself, right? You don't want to constantly write down, a bigger expression than you have to, because every time you copy something down. And another point, every time you copy something down or look away from your piece of paper and you come back to it, there's more probability of making errors, right? So what you want to do is simplify your expressions that you're working with as much as possible during the work, during the process. That way you eliminate simple human error involved in it, okay? So what we're going to do is, let a different letter equal this, right? Let's use Q, for example. Q is one of the ones that you use in general, or U, or Z, or T, whatever you want, right? Anything other than A, B, or C, because we already have A and B and C, and anything other than an X, because we already have an X. And Y in general is off limits, because Y is, in mathematics, it has the assumption that it's your f of x, okay? So we're going to use Q. So we're going to say let. So in our original expression, wherever we see x minus 2 over x, we're going to substitute it with Q. Simplifies our expression, right? Simplifies our equation. So now we got negative 3q squared plus 5q plus 2, right? And this guy we can factor. Again, this is something that you could factor using the 4-step method. You could grab the negative 3, bring it over, it becomes negative 6. Two numbers that multiply to give you negative 6, and that to give you 5 is going to be positive 6 and negative 1. And you can use the 4-step method and solve for this, right? We're going to use the quadratic formula. And right now I'm sticking with numbers that factor fairly easily, because I don't feel like bringing out the calculator and punching in the numbers, right? I don't feel like carrying over the root symbols, working with the radicals left and right, Because whenever you get something like that, if you're solving for it, they're either going to say, solve to certain decimal places or give exact values for it. If they say exact values, what you have to do is keep everything in their root form, in their irrational form, but no decimals, right? If they ask you to round something up to a certain number of decimals, then you're going to have to round things up to a certain number of decimals. Right now, we're going to stay away from that because we're just learning the processes. Later on, when we start, I'm going to go through a series, or when we finish all the different factoring techniques, we're going to go into, we're going to do a whole bunch of complicated problems. And during that process, we're going to get into stuff where, you can't factor out simply. Right now, this one we can, right? But we're still going to use a quadratic formula for this. You could use the 4-step method and still use your substitution, your let statement, right? But since we're on the quadratic formula, let's use the quadratic formula. So what we're going to have is Q is equal to our quadratic formula. So negative B, our B is 5, right? If you want, you could write out your A, B, and C, right? Your A is negative 3, your B is 5, and your C is 2. And it's a good idea to do this just so you eliminate any, human error or your mind playing tricks on you. So it's going to be negative b, which is going to be negative 5, plus or minus the square root of b squared, which is going to be 5 squared, minus 4 times negative 3 times 2. All of it divided by 2a, which is 2 times negative 3. So right now what we're going to have is negative 5 So Q is going to be equal to, let's just solve this mentally, right? We've got negative 5 plus 7 is going to be 2. Oops, I forgot the negative here. Don't forget it's negative 6 coming down, right? These types of mistakes cost a lot of marks during exams, okay? So you should always be rechecking, scanning over your work, trying to eliminate these types of simple errors, right? So you got negative 5 plus 7, which is 2. 2 divided by negative 6 is going to be negative 1 over 3, right? 2 over 6 is a third, and it's negative, right? So it's going to be negative 1 over 3. That's our first answer for Q. The second answer is going to be negative 5 minus 7 is negative 12. Negative 12 divided by negative 6 is 2. So our two answers we got for solving this quadratic equation, right, is negative a third and 2. Now we haven't finished this question yet because we weren't looking to solve for Q. Q is something that we introduced in the algorithm, in the process of solving this equation, right, to simplify our expression, right? We're trying to solve for x, right? Because this would say solve for x. So what we're going to do is resubstitute x minus 2 over x for Q and solve for this. And these guys, we've talked about before when we're solving equations from series 3a. This is just cross multiplication, right? We've got one fraction equals to another fraction. So we're going to grab the x, multiply it up here, grab the 3, multiply it up here. So 3, when it comes up here, multiplies both of them, so it becomes 3x minus 6. And this guy, x comes up, multiplies negative 1, it's just negative x. Right? Now if you're solving this, so x is going to be 6 divided by 4, which is 2 over 3. Oh, sorry, which is 3 over 2, right? And that's one of our x values, right? What we're going to do is solve this one now. Cross multiply, 2 is just 2 over 1. So you're just going to cross multiply this up. Cross multiply to 1 up, right? Fraction equals another fraction. So it's just going to be x minus 2 is equal to 2x. So your answer here is going to be x is equal to negative 2. And those are our answers for our original problem, for our original question, which was, the expression that we had, what was it? Negative 3 bracket x minus 2 all, over x all squared, blah, 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 right? Our original question was asking us to solve for the x value, right? Not to solve for q. Q was, again, something that we introduced into the process to make the expression simpler for us to solve. So what we did was use the let statement to simplify things for us. That way we could work with it, crunch, 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 get down to this level, and then resubstitute whatever our let statement was for the x's and solve for the x's and get our answers to the original question. Okay? Now, when you get the answers here, you're not really done. In general, you could be done depending on the question that you're being asked in the exam, in the homework assignment, or if you're working somewhere, if your work requires you to solve for quadratic equations, and there are jobs in real life that you get where you have to do this type of work, right? If in general they're more complicated, you run them through a computer and the computer spits out your answer, right? Or the process spits out your answer, your algorithm spits out your answer. Sometimes you have to do things manually, right? It's a pretty good idea to go through the process and solve for them to get to the answers. Make sure, to do a double check, because if you're doing anything in real life, if there's money on the line, or if there's something else on the line that you have, your job depends on it, or people's lives depend on it, or whatever it is, if you're building something, you better be checking your solutions, right? Checking your answers. And that's what we're going to do right now. We're going to check both these answers. So what we got is, that's our original expression, right? And these are our answers we got for the x. So what we're going to do is check our answers, okay? And we've done some of the stuff in Series 3a, checking solutions, right? So what we're going to do is just plug in x is equal to negative 2. We're going to do this one. X is equal to negative 2 on the left-hand side of the equation to see if it equals the right-hand side of the equation. Now, for us, right now, the question is easy. The right-handed equation is just 0. So right-handed equation is just 0, right? Our left-handed equation is just going to be this guy with the x as equal to negative 2 subbed in. So what we're going to have is So our left-hand side of the equation is negative 3. So what we're going to do is just simplify this, crunch it to see if this side is equal to 0. If it is, then we know that answer is correct. So negative 2 minus plus 2. So negative 12 plus 10 plus 2, well, that's just 0. So right away, we got left-hand side of this equation, when you plug in x is equal to negative 2 is equal to 0, right-hand side of the equation is equal to 0. So this works out, so we know this answer is correct. Okay. What we're going to do is do it for this one as well. So I'm not going to bother writing down the original expression first, because this one's going to take us a little bit longer because there's fractions and there's a nice little storm coming in, so it's going to start raining soon, so I got to zoom out of here so the camera doesn't get wet, okay? So we're checking to see if x is equal to 3 over 2, which is 1.5, works in our original expression, right? Should we stay with fractions? Let's use the decimals. So 3 over 2 is 1.5, right? So what we got right now is going to be negative. So this is going to be negative 3. 1.5 minus 2 is going to be 0.5. 0.5 divided by 1.5. Ah, should have stuck with fractions. Let's stick with fractions with this, okay? So I made a mistake. Be careful with your mistakes. I know this isn't going to work out, but I made a mistake here, right? Because this isn't a half. That's 1.5 minus 2 is negative a half. So this guy should be negative, that guy should be negative, that guy's negative, that guy's negative, and that guy's negative. So all of these become negative. Right? So what we have here is, this is negative 5. I personally make a lot of mistakes when I'm doing these types of problems. So be careful with this, okay? So all of those should be negative. So what ends up being in the middle here is negative a third, right? So negative, this guy's positive. Negative 1 over 3 squared is 1 over 9. And you simplify this, it becomes negative 3 here, so it's a negative a third plus negative 5 over 3 plus 2. Now these guys have the same common denominator, and you can add these. So negative a third plus negative 5, negative 1 plus negative 5 is negative 6. So this becomes negative 6 over 3 plus 2. Negative 6 divided by 3 is negative 2 plus 2. So this side is equal to 0, which is what we wanted. We wanted the right side to be equal to 0 too. So our check works out. So our answer of x is equal to 3 over 2 is correct. So both our answers work out through the check. And you know, this is sort of a fairly complicated, not a fairly complicated, but a medium level question that you would end up getting when it comes to solving something in a quadratic formula, and when it comes to checking it, because the checking requires a fair bit of number crunching as well. Okay, so you know, this is using the let statement to simplify questions for you, to simplify expressions for you to be able to crunch numbers and solve for your quadratic equations, or solve for any type of equations, right? Because our original question was not a quadratic equation. We converted it into quadratic. It wasn't a quadratic polynomial. We converted it into quadratic polynomial. We solved it as a quadratic, and then we substituted back in what q was for the x's, and then solved for the x values there, right? Okay, hopefully this all made sense. There's a fair bit of stuff here, and we will definitely use substitution and the let statement a lot further when we get into, you know, factoring and graphing polynomials and solving for equations.